Imagine driving across a highway that doesn't stand on the seabed. It floats, and this one is planned to stretch for roughly 5.5 kilometers across deep water. But making a bridge float is only the beginning. The real challenge is keeping thousands of tons of structure stable, while waves, wind, currents, and traffic are constantly trying to move it. So how do engineers turn a floating structure into a highway that can actually stay in place? That's where the engineering gets seriously complicated. The challenge begins with the fjord itself. Bjørnafjorden is wide, deep, and exposed to harsh marine conditions. There is no simple place to plant a conventional bridge foundation across the middle of the water. And that creates the central engineering problem. How do you build a bridge across several miles of deep water without filling the fjord with massive foundations? The answer is not to fight the water. It is to make the bridge work with it. Instead of carrying the entire bridge on traditional foundations, the concept uses floating pontoons to support the structure. Think of each pontoon as a giant floating platform. But simply making something float is the easy part. The real challenge is keeping a bridge stable while the water beneath it is constantly moving. Waves push from the side, wind pushes across the deck, and traffic adds moving loads from above. So the engineers had to solve a much bigger question. How do you make a floating structure behave like a rigid bridge? The proposed Bjørnafjorden solution combines floating support with a carefully controlled structural system. The pontoons provide buoyancy, while the bridge structure connects them into one continuous system. But the bridge cannot simply drift with the current. Its position has to be controlled. That means the system must resist horizontal forces while still allowing the floating elements to respond safely to the movement of the water. And this is where the design becomes especially interesting. Instead of pretending the fjord is motionless, the engineers designed the bridge around the fact that it moves. The proposed Bjørnafjorden solution combines floating support with a carefully controlled structural system. The pontoons provide buoyancy, while the bridge structure connects them into one continuous system. But the bridge cannot simply drift with the current. Its position has to be controlled. That means the system must resist horizontal forces while still allowing the floating elements to respond safely to the movement of the water. And this is where the design becomes especially interesting. Instead of pretending the fjord is motionless, the engineers designed the bridge around the fact that it moves.
Engage primary winches. Synchronized lift initiated. Tension on taglines maintained.
The fjord is
Load
not just
stable.
wide, it is deep. That makes conventional construction methods far more difficult. Instead of building a line of enormous foundations across the seabed, the floating concept reduces the need for conventional supports in the deepest sections. But that creates a trade-off. The deeper the water, the more important the floating and anchoring system becomes. Every component has to perform its job while exposed to waves, wind, currents, and repeated loading. So the question changes again. Can a floating bridge remain reliable for decades under those conditions?
Lowering. Slow, slow. Alignment check. Good. Left. Engage. Now lock. Secure.
That is why this project is
secure,
less about one
stable.
spectacular
Verified.
piece
Proceeding
of
to the next
concrete
section. Check the
or
tension
steel.
on that far cable, please.
It is about coordination. The floating elements support the bridge. The structural system distributes loads. The anchoring system controls movement. And the entire bridge has to respond as one engineered system. This is the key idea behind the project. The bridge does not need to completely eliminate movement. It needs to control movement. That distinction is what makes the concept possible. Now step back and look at the full scale. A bridge extending approximately 5.5 kilometers across a fjord is no ordinary floating structure. It has to provide a continuous roadway while operating in an environment that never stops moving. And that is what makes the project so unusual. On land, engineers can build massive foundations and anchor a bridge to the ground. Here, much of the support has to float. The ground is no longer the obvious foundation. The water becomes part of the engineering problem and part of the solution. And that brings us back to the question at the heart of Bjørnafjorden. How can engineers build a bridge this long across deep water? Not by creating a conventional bridge and somehow forcing it onto the fjord, but by designing a system where buoyancy, structure, and controlled movement work together. That is the real breakthrough behind the floating bridge concept. A 5.5-kilometer crossing does not have to stand entirely on the seabed. It can float. And when engineering stops trying to defeat the environment and starts designing around it, an enormous fjord suddenly becomes a bridgeable space. If you want to see how the world's most ambitious mega projects are engineered, subscribe to Mega Build World.